welcome back. We are going to start our second semester with a little bit of review from Algebra 1. We are making sure that we're covering systems of equations and graphing, as this is something that is important when our juniors take the SAT later this fall, well, spring actually. So we're going to go ahead and do some review. So none of this should be new, but we're going to go through it step by step just in case. So we have systems of equations, and we're going to start with defining what is a system of equations. A system of equations is a set of two or more equations containing two or more variables for which a common solution is sought. What does it mean to solve a solution of equations? It means that an ordered pair satisfies each equation. To be more specific, an ordered pair is the solution. It makes both the equations true. So right now we're going to go ahead and start with deciding if we have an ordered pair, is it a solution to the system of equations that we are given. So for this first question here, we have -2, 4, where x is -2 and y is 4, and we're going to plug that into both equations and check to see that they are correct. So I have y for that top equation is 4, and that's equal to 4 times x, which is -2, plus 8. And we are not sure if those are equal or not, so I put my question mark above my equal sign, and then I'll solve through, and if it works out, then we have a partly true system of equations, and then we'll have to check the second one. So I have 4 times -2, and that is equal to -8 plus 8. -8 plus 8 is equal to 0. So this is saying that 4 is equal to 0. Well, that's not true. I don't even have to check the other equation now because this already isn't true. If it was true, I would have to check for this one. But because it's not, I already know that this is not a solution because it did not satisfy the first equation. So not a solution. And that is my answer on this one, that it is not a solution. Alright, let's check the next one. So I have 1 and 5. My first equation, I have -5 times x, which is 1, plus 6 times y, which is 5, and it says that that should be equal to 25. So I have -5 times 1, that's still -5, plus 6 times 5 is 30, and that is supposed to be equal to 25, which in this case that does work because 30 minus 5 is equal to 25. So this checks out because 25 is equal to 25. So that checks out. Now we have to check the other equation. So I have -7 times x, which is 1, plus 8 times y, which is 5, is equal to 33, and we are going to see if that works out. -7 times 1 is still -7, plus 8 times 5 is equal to 40, and we think that that is going to be equal to 33. 40 minus 7 is 33, so we have 33 is equal to 33. That checks out. It works for both of them, so this is a solution. If you want to be more specific in your answer, you could write that. The 0.15 is a solution, or you could say the ordered pair 1, 5 satisfies both equations. Alright, so now that we've seen what it looks like to check if our solution is true, if it works, we're going to talk about the 3 different ways we can solve an equation. So we have graphing, substitution, and elimination. We're going to start with graphing today, and then we will work with substitution and elimination tomorrow. These are our 3 methods for solving a system of equations. We also have 3 possible outcomes. So you're either going to have one unique solution, infinitely many solutions, or no solution. And we'll talk about the specifics of what that looks like as we are going. We are going to start with one unique solution. For one unique solution, that means that our lines, because we have 2 linear equations that make up a system of equations, those 2 linear equations will only cross once in one place. and that will be our one unique solution. If they're infinitely many, they'd be the same line, and if they have no solutions, then they wouldn't ever cross. Most of our systems will have one unique solution, and that's what we will start with. And again, I just said we were going to start with graphing, so let's go ahead and start with this first example. I'm going to pull out my ruler. I'm going to need it several times for this one. And I'm going to designate my first equation to be blue, and then my second equation I will make green, and we will look to see where these two lines intersect, and that will be our solution. So I have y is equal to 2x minus 4. Remember, we have this form, slope-intercept form, which says y is equal to mx plus b, which tells us the slope and the y-intercept. In this situation, I have -4 for my y-intercept, so that is where I'm going to put my first point on my graph at -4. And then I'm going to use my slope, which is a +2, to find my second point. So since that's just 2, that's really 2 over 1, so I'm going to go up 2 over 1, and that will be my second point. Now I can use my ruler to draw that line. Alright, that is looking good there. So I'm going to draw my line right there. I'll move my ruler out of the way. And this needs to be labeled. I'm going to write the equation right by it. So I have y is equal to 2x minus 4. Now I'm going to switch colors here to try to keep this clear as to which line is which. So now I have y is equal to x plus 2, so I have mx plus b. My y-intercept is +2, so my point will be at 2, 0, 2. And now I need to use my slope, which is 1, so I go up 1 over 1. So my next point is right there, because I went up 1 over 1. And I'm going to use my ruler, and I'm going to graph that line. And I want to make sure that I'm plotting these points and drawing my lines long enough so that there is an intersection point, which I did see that it intersected, and we'll get the exact measure of that in just a moment. First, we're going to label our line, and I'm actually noticing that my blue line could be a little straighter, so I'm going to fix that a second. So I have this line. My points are in good places, but my line, when I traced my ruler, didn't go exactly where I wanted it to, so we're going to try that again. Okay, so I have y is equal to x plus 2, that's my second line. And now I am looking for that point of intersection. As I'm looking at my graph, I'm noticing that they intersect at this point right here. So I'm going to draw a point right on that, and they are crossing at that point, which is 6, 8 over 6 up 8. So the answer to my system of equations is this ordered pair, which is the point 6, 8. And I can zoom in there a little so you can see a little better as to exactly where we are intersecting. That's our point. So we were going up 1 over 1, and then here we were going on a slope of up 2 over 1, and they intersect at this point. Alright, let's take a look at another example of that. So if we scroll down the page, we have this new system where we have the equations 2y is equal to 2x minus 4 and 3y plus 6x is equal to 12. It is possible to graph those in their equation right now. So you would pick a point, plug it in, and solve. I'm going to rearrange them instead. So we're going to go back to that y is equal to mx plus b. So I have 2y is equal to 2x minus 4, and I want y by itself, so I'm going to divide out 2 from both sides. That leaves me with y is equal to x minus 2. And then the other equation we will get to after we graph this one. So y equals x minus 2, that means I have a y-intercept of -2, and my slope is a 1 because there's nothing there, so I have a positive 1. So I'm going up 1 over 1, very similar to a different equation we were just looking at. So I'm going to plot my points there, and that is looking good. So I'll cross our lines there, and then I will label that line, which I'm checking to make sure I got that straight, and it's a little off, so let's try that one more time. If you don't have your line exactly straight, your answer is going to be a little off. So we want to try to get as close as possible. And we're still off, so let's try it one more time. Okay, that's much better. Alright, there's our line. That is the y is equal to x minus 2, or you could label that with its original form of 2y minus 2x minus, or 2y equals 2x minus 4. Now we're going to switch to the other line. So I have 3y plus 6x is equal to 12, and I need to rearrange that so that we have y is equal to mx plus b. So I'm going to start by moving this 6x. So I'm going to subtract 6x from both sides. That leaves me with 3y is equal to 12 minus 6x. And I'm going to divide out the 3 from both sides. That gives me y is equal to 4 minus 2x. And this is something that can be rearranged from a property you learned about in algebra. That's the commutative property. So I can swap those around. So I really have y is equal to negative 2x plus 4. So my y-intercept is at a positive 4. And my slope is negative this time. It's negative 2. So that means my y's are going down. So I'm going down 2 over 1. Down 2 over 1. And that will be, those 2 points will help me plot my line. So I take this line and I'm going to do my best to line that up so that it connects through all the points that it needs to go through. And it looks like we've about got it, so we'll try there. And that did work out nicely for me. I'm going to put my ruler away now. And that is our line, which I'm going to label as y is equal to negative 2x plus 4. And now I'm going to look for their point of intersection. If I zoom in closer, you'll be able to see it a little better here. So they intersect, and my lines aren't perfect, so you're not seeing exactly where it goes through, but it is going through right on this vertex there, that intersection of our lattice points. So our point of intersection is at the point 2, 0. So we went over 2, up 0. So my solution to this is the point 2, 0. That is my answer. Alright, so this part you've all done before, but there is something, we have this nice tool that you all have on your Chromebooks and that are available in our classrooms called a graphing calculator. And the graphing calculator actually can do all of this for you. So if you're using your graphing calculator, you don't even have to do much other than the rearranging. It'll graph the line for you, and it can find the intersection for you. And we're going to go through how to do that. So sometimes you will need to graph it by hand, but there is the graphing calculator method too. The one catch is you do have to have it in slope-intercept form, so it has to be in the form y equals mx plus b. So you'll have to rearrange it, but once you've rearranged it, it's not so bad. And that's what this line here says. Solving systems on the calculator is great, but it requires slope-intercept form, meaning our equations have to be written in the form y is equal to mx plus b, where m is the slope and b is the y-intercept. I'm going to zoom in on the instructions here. I'm just going to read through these once. I'm not going to show you this Desmos method. You can follow the steps if you are using Desmos. You should all be using the TI-84 graphing calculator because that's what's on your Chromebooks. And those are the instructions that we're going to go through and actually show through the steps. So I have here, you go to desmos.com, and in the graphing calculator part, you type y equals 3x minus 9 in line 1, and y equals x plus 2 in line 2, or whatever your two equations are. And then you'll click on the intersection point, and the answer is displayed. And these are your system of equations for this question, which is why that's what we have in our directions. But you wouldn't necessarily type in this specific equation, you type in whichever one you're given. And if we're doing this correctly, and we will check it, our answer should come out to be 5.5 and 7.5, but we'll find out with our graphing calculator in just a moment here. So on the graphing calculator, there's a few more steps here, but we can talk more in detail as to why we're using this and not Desmos, but for now, these are the steps. And it looks like a lot, but once you've done it once or twice, it's really not so bad. So you're going to start by hitting the y equals button. Then you're going to type the 3x minus 9 in y1 line, and type x plus 2 in the y2 line. Then you're going to hit graph. Then you're going to hit second trace and select option number 5. You're going to align your cursor with the corresponding line as stated on the bottom of the calculator screen. You're going to get as close to your intersection point as possible. Hit enter. Continue the process for the second line, and it will give you your intersection guess. The answer is then displayed at the bottom of the screen. Okay, so that sounds like a lot, and it's kind of confusing. It'll make more sense as we're pressing the buttons. So we're going to use those same equations here. And I'm going to see if I can get my calculator to show up on top of the screen here. I think I can. Let me try that one more time. Okay. And, okay, there we go. So hopefully that will be big enough to see what we're doing here. You're going to start with this y equals button. It's the top left button. And when we click that button, it opens up a screen that looks something like this. If you have the non-color edition, this will all just be black, so you won't be able to see the colors as nicely, but that's alright. And we're going to type our first equation. So we have y1. So this is your y. So y equals, then you have to type in the second part of your equation. So in our question, we have y equals 3x minus 9. And that I already typed, but I'll go through how to type that here. So we have our 3 down here. 3x is this button here, so it's right next to the alpha button. You click that once, that gives you your x. And then we had minus 9, so I hit the subtraction button, and 9. If we needed a negative, you'd have to press this button down here. That's our negative. But we're using subtraction, so we don't really need that at the moment. Next, you're going to hit graph. This graph button, this top right button, when you hit graph, it plots your lines for you. It works very quickly to get those in there. And now that we have our lines graphed, we can use the calculator to find the intersection point. To do that, we hit second and this trace button. So when you hit second, you are telling the calculator, rather than the button you're pressing, but you're looking at the little blue letters that are right above it. And I don't think it lets me zoom in there. It doesn't. I'll see if I can, might be better to open this in a screen to itself, but I'll give you a link to another video of how to do this on the calculator so that you can see this a little better. We're going to hit second trace, and it's going to give you these options here. We are looking for the intersection point, so we are going to select option number 5. You can either curse down and hit enter once you get there, or you can just select the number 5, and that will select our line for us. Now we have these cursors on our line, and I'm going to try to get them as close as possible using this arrow button. So I'm going to arrow over until I get closer to that point of intersection because I can see it there. That's fairly close, so I'm going to hit enter. Now it has this third line here. Some of the other calculators don't have that line pop up, but it will still work. So once you get that, you're going to continue to the other side of the intersection point, then you're going to hit enter again. And now on your screen, it gives you intersection and then the point right here. And your intersection is at the point 5.5, 7.5. So that's how we use the graphing calculator. Alright, I will try to use a bigger screen when we go through our next example. So let's clear this out. I'm going to close out the calculator here. If it will let me, there we go. And we're going to solve this system of equations using a graphing calculator. So first thing we need to do is put them in slope-intercept form. So I have 2y plus 4 is equal to 6x. I'm going to start by subtracting 4 out from both sides. That leaves me with 2y is equal to 6x minus 4. Now I need to get that 2 out, so I'm going to divide out 2 from both sides. That leaves me with y is equal to 3x minus 2. Right, so now I have this first equation. Now I need to do the same thing on the second equation. So I have 3y plus 12x equals 12. I still need y by itself, so I'm going to subtract out 12x from both sides. 3y is equal to 12 minus 12x. I'm going to divide out the 3 from both sides. That leaves me with y is equal to 4 minus 4x. So now I have my two equations. And the calculator doesn't need these two things to be switched, but we're going to switch them anyways. So I really have y is equal to negative 4x plus 4. So those are my two equations that I'm going to put in my calculator. So I have 3x minus 2 and negative 4x plus 4. I probably won't remember both, so we might have to come back and check. So we have 3x minus 2, that's our first one. So in my calculator, I'm going to hit y equals. I'm going to clear out what's already in there. In my first equation, my y1, I believe I had 3x minus 2. So 3x minus 2. Enter. And now I need my second equation, which was negative 4x plus 4. So I'm going to go back to my calculator. I have negative 4x minus 4. Now I'm going to hit graph. I'm going to hit second trace. I'm going to select option number 5. Left bound, so let's move our cursor to the left side of the intersection. Right bound, so we're going to go to the right side of the intersection. And now it found our intersection point for us at the point negative 0.28. On this one we're going to round to 1 decimal point, but normally you should round to 2. So I have negative 0.3 and negative 2.9. We'll go back to our notes. So we have our solution right here, negative 0.3 and negative 2.9. Like I mentioned before, I will be posting an additional video for you to watch if you need some extra support on how to use the graphing calculator to find your solution. And then we'll pick back up with elimination and substitution.